Hello students, welcome back to the Tantray physics classes. It is the second lecture on gravitation. In first lecture I discussed force between the two bodies, gravitation force between the two bodies. I gave you the equation F is equal to G m1 m2 by r square, and I already told the weak force. It becomes meaningful only between the heavenly bodies because they are massive, and between two small objects the force is almost negligible. And I also gave you the acceleration due to gravity on the surface of the earth, how acceleration due to gravity varies when we go up into the space from the earth's surface. Of course, that was acceleration due to gravity outside the earth. And acceleration due to gravity becomes the property of a point. It is not the property of the object which is placed at that point. क्योंकि हर एक ऑब्जेक्ट का एक्सेलरेशन सेम है at the same space point. जो हमने देखा है कि एक्सेलरेशन ड्यू टू ग्रेविटी डज नॉट डिपेंड ऑन द मास ऑफ द ऑब्जेक्ट, तो ऑब्जेक्ट के मास पर तो डिपेंड करता ही नहीं है, इसलिए एक्सेलरेशन ड्यू टू ग्रेविटी बिकम्स द फंक्शन ऑफ अ स्पेस पॉइंट. सो टुडे आई विल एक्सप्लेन you how the acceleration due to gravity varies with height, with altitude from the surface of the earth upwards. So variation of g, acceleration due to gravity with height. ये हमारा क्वेश्चन है, आज का क्वेश्चन. देखते हैं हम इसको कैसे करते हैं. ओके, ये है अर्थ, ये है रेडियस ऑफ द अर्थ, और मास समझो m है, और ये पॉइंट है स्पेस पॉइंट. ये पॉइंट, कोई भी ऑब्जेक्ट यहां रखो तो उसका एक्सेलरेशन वही होगा जो किसी और ऑब्जेक्ट का होगा, क्योंकि यहां जो मैं ऑब्जेक्ट रखूंगा उसका एक्सेलरेशन समझो g, ओके, जी आर, जी और नीचे r, तो r इज द डिस्टेंस फ्रॉम द सेंटर टू दिस पॉइंट, दैट इज r, वेयर r इज ग्रेटर इक्वल टू कैपिटल R. मतलब ये जो पॉइंट है, ये अर्थ के बाहर है, तो उसका मैथमेटिकली दैट मींस r, स्मॉल r इज ग्रेटर इक्वल टू कैपिटल R. ये जो स्मॉल r है ये कैपिटल R से ज्यादा है, तभी तो पॉइंट अर्थ के बाहर है. तो क्या होता है एक्सेलरेशन ड्यू टू ग्रेविटी देयर? जी आर, दैट इज जी एम बाय आर स्क्वायर. वी हैव ऑलरेडी डन दिस. आर स्क्वायर इज दिस डिस्टेंस स्क्वायर. एम इज मास ऑफ द अर्थ, एंड मास ऑफ द ऑब्जेक्ट डज नॉट काउंट. वो यहां है नहीं, क्योंकि मास ऑफ द ऑब्जेक्ट पर डिपेंड नहीं करता है. वो हमने लास्ट लेक्चर में आपको एक्सप्लेन किया. तो समझो यहां से यहां तक के एच का हाइट है, तो फिर ये जो r है, what should I write for this r? Because r is from here to the point, that is gr is equal to gm by, ये r जो है it is r plus h. This small r is r plus h, this r plus h whole square, right? तो आगे जाकर के g, अब it is not function of h, so this r you can replace by h, gh. मतलब ये है कि acceleration due to gravity at a height h above the surface of the earth, that will make it gm by, ये r को कॉमन निकालिए, ये हुआ 1 प्लस h by r, इसका भी स्क्वायर और इसका भी स्क्वायर. ये r को कॉमन लेकर के मैंने ये कर दिया, ठीक है. आई वांट टू डू समथिंग एल्स हियर. gh is equal to gm by r square, that is g on the surface of the earth, divided by, ये gm by capital R square is acceleration due to gravity on the surface of the earth, divided by 1 plus h by r whole square. This is the equation for the acceleration due to gravity at a height h above the ground. G divided by 1 plus h by r whole square. ये है हमारा इक्वेशन, the acceleration due to gravity as a function of h. मतलब साफ है कि अगर आप बहुत दूर जाओगे, h बढ़ता जाएगा, तो acceleration due to gravity जो है वो कम होता जाएगा. और what is this? This is the equation, okay? The equation 2 gives the variation of acceleration due to gravity with height, with altitude भी कह सकते हो, altitude, with altitude. ये है हमारा जो हमने इक्वेशन निकाला. Okay. Now, second point that I want to tell you, let me pull out a graph. Let me pull out a graph. Let me plot a graph between R versus acceleration due to gravity. This is the center. Graphically, this is the center of the Earth. And if you go away from the center of the Earth, what is acceleration due to gravity? You don't know what happens to acceleration due to gravity inside the Earth. But from surface of the Earth onwards, we know the equation. So, what is acceleration due to gravity at the center of the Earth? That is something that we don't know because we don't have an equation from here to here. Let's wait for that. We don't know here. No, and no, up to R. We don't know the equation up to R. But at R, the acceleration due to gravity is this one, gm by r square. Acceleration due to gravity at the center, that we have to find out at some other time. So what is the acceleration here? Yahan up to here, we don't know because we don't know what's the equation of acceleration due to gravity inside the Earth. When I will do that, then I will complete the graph from here to here. But from at a radius r, the acceleration is given by this, right? And from onwards, upwards, we know the equation that decreases as 1 by r square. Proportional to 1 by r square. So up to the surface, the acceleration due to gravity, we don't know. We will find an equation for that. But from surface onwards, the acceleration due to gravity decreases and is inversely proportional to r square. Okay, this is the graphics. If this graph is a hyperbolic graph, rectangular hyperbola is a hyperbolic graph. Hyperbolic graph. Okay, now let me give at least one example. Let me give you one example. Example: what is the acceleration due to gravity? Due to gravity at a height h equal to 2r. At a height h is equal to 2r above the surface of the Earth. Above the surface of the Earth. मतलब ये अर्थ है, ये रेडियस है, तो मुझे यहां पर एक्सेलरेशन ड्यू टू ग्रेविटी निकालना है जो सरफेस से कितना दूर है, h, ठीक, और वो 2r के बराबर है. ठीक है, लेट्स यूज द फॉर्मूला g h is equal to, what is that, g, this g is the surface of the Earth acceleration due to gravity on the surface of the Earth, this g, by 1 plus h by r whole square. This is the formula that we just got. ठीक है ना? तो बताइए जी एच किसके बराबर लिखेंगे आप? कैसे करेंगे? एच को सबस्टिट्यूट करोगे ना आप, तो एच को सबस्टिट्यूट करने के बाद थोड़े से एक दो स्टेप पे ये हो जाएगा. तो जी एच इज इक्वल टू, दैट इज जी डिवाइड बाय 1 प्लस व्हाट इज एच, दैट इज 2r बाय r होल स्क्वायर. दैट इज जी बाय, ये खत्म हुआ, 1 प्लस 2 होल स्क्वायर. दैट इज जी एच इज इक्वल टू जी बाय 3 9. दैट इज द आंसर. सो यहां हो जाएगा g by 9, while acceleration due to gravity on the surface is g, that is 9.8, and here it is 9.8 divided by 9. That will be 1.02. 1.02. That will be the answer. Meter per second square. Meter per second square. So it is very obvious now जब आप सरफेस से ऊपर जाओगे अर्थ के, जरूरी नहीं अर्थ हो, कोई भी स्फीयर हो, सॉलिड स्फीयर, कोई भी सॉलिड स्फीयर हो, उसका एक्सेलरेशन का वेरिएशन इसी तरह से होता है. वी टेक द एग्जांपल ऑफ द अर्थ, बट इट कैन बी अ प्लैनेट, इट कैन बी अ स्टार, इट कैन बी एनी स्फेरिकल ऑब्जेक्ट जिसका एक्सेलरेशन वेरी होता हो फ्रॉम सरफेस ऑनवर्ड्स एज 1/r². This is second lecture on gravitation, and so you just concentrate on these basic concepts, and we will continue our series on this lecture series on gravitation till I complete it. Thank you.